Hello, everyone, and welcome to the Novus Knowledge webinar on maximize feed cost savings through efficient usage of alternative raw materials. I'm Narissa Sachdev, Marketing Communications Manager for Asia Pacific Novus International. And today I'll be your host. Thank you, everyone, very much for taking the time today to be with us here. And we hope that you gain useful insights from our topics today, which will be presented by Professor Ravi Ravindran, Emeritus Professor from Massey University, New Zealand. We are also joined by Dr. Mercedes Vasquez Anon, Senior Director of Research and Development from Novus International. For today, you will have the opportunity to ask us questions through text on the panel tab on the right-hand side corner of the screen. And throughout this presentation, you can send us the questions which will be answered during the live Q&A session during the panel discussion at the end of both the presentations. Now, let me introduce to you Professor Ravi. Professor Ravi Ravindran is an emeritus professor from Massey University, New Zealand. He graduated with a BSc in agriculture from the University of Sri Lanka and an MSc and PhD in animal nutrition from Virginia Tech University, USA. He held academic and research positions in Sri Lanka, Canada, USA, and Australia prior to moving to New Zealand in 1998. Professor Ravi has a distinguished international career in nutritional science, having published in excess of 600 scientific works, including 330 journal articles, 3 books, and over 40 book chapters. He's acknowledged as a world leader in the area of measurement of nutrient availability in poultry and feed enzymes. Professor Ravi has received several awards, including the American Feed Industry Association Poultry Nutrition Research Award, as being an author of top 1% most cited paper in poultry science. This is by no means everything that Professor Ravi has achieved in this brief introduction. But if you want to read more, you can definitely visit the Novus event site and read more on his profile. But now, without further ado, I would like to invite Professor Ravi Ravindran to give the first presentation for today on the efficient usage of alternative raw materials, challenges, and opportunities. Professor Ravi.
Thank you, Narissa, for this kind introduction. And I don't have to tell the audience the perfect storm we are in currently. It's a big crisis. And so the subject we are going to talk about is quite topical. Yeah, so we are going to talk about, for the next 40 minutes or so, the alternative raw materials, which is a current topic of interest in the poultry industry. And I'm going to discuss very briefly about the various options available to us and the challenges which we are faced with. These are not new challenges. We have known these challenges for a long time, and also how these risks associated with alternative raw materials can be mitigated. The poultry industry currently is having the best of times as well as the worst of times. In terms of consumption and production, broiler meat is, as you all know, is the #1 animal protein globally, and the industry is continuing to grow. The trend in increased production of broilers is going to continue into the future compared to most of the other animal industries. But this is a good news. But along with this good news, we have some bad news. It comes with major challenges, number of challenges, multiple challenges in terms of raw materials. Speci- Especially, there's going to be increasing appetite if you want to grow the poultry industry. There's going to be increasing appetite and the supply of what we call the big two, corn and soybean meal. And this had been always a big risk, big threat to the poultry industry, just the reliance on these two ingredients. This is not a new challenge. The availability and the cost of raw materials have always been a challenge, and I could say these were the known unknowns. We know it's going to be a major issue. At the same time, we don't know how they are going to affect. Of course, the first, what you see in this slide are the four major factors which will influence the availability of raw material, especially the conventional raw materials, corn and soybean meal. Weather had been always number one. Then, of course, we have a geopolitics and global trade policies which can come into play from time to time. And during the 2000s, we saw fossil oil price, the price of the fossil oil and government mandates also had an effect on the ingredient supply. Next one, please. And unfortunately, we had other issues coming into picture. And COVID-19, 3 years back, was an unexpected addition, created quite a bit of challenges, and which has been more recently aggravated by the conflict in Ukraine. In terms of what you're talking about is in terms of interruption in the supply chain, started in 2019 and continues to this day. And it's going to be a bumpy ride in the years ahead. And it's not going to go away within the next year or so. I think we can expect the issue to continue into the future. Essentially, the supply chain problems is causing higher shipping costs, leading to higher ingredient costs of conventional ingredients. So the most obvious strategy, which we all know, is to look for the potential alternatives, possibly cheaper ones, and also look into new technologies which can help us to either replace or reduce the inclusion levels of corn and soybean meal. We'll come back to this a bit later. And the potential alternatives ingredients is not a new phenomenon. We have always been interested in the cheaper alternative ingredients since the advent of the commercial poultry industry. That will be around 1950s. I'll come back to that shortly. And but between this period, from the 1950s to the current times, we have seen interest spiking every time when there's a problem with the availability or the cost of the big two, corn and soybean meal. So this is a time we all of a sudden again become interested in alternating ingredients and doing research or start looking at various options. What you see here, what you can see from here is the two diets, comparison of two diets in the 1950s when the commercial poultry industry started. When you talk about the birth of the commercial poultry industry, it started in the mid 1940s with the recognition that crossbreeding can increase the size and growth of the broilers, and this can actually help to grow as well as expand the poultry industry. So we are comparing the start of the poultry industry, the diets, and the current poultry diets. It's just an example. If you look at the poultry diets, broiler diets, broiler starter diet currently, you can see we have become less diverse. We are just focusing on four ingredients: corns, soybean meal, a lipid source, and animal protein source to balance. And then, of course, we have the various vitamins, minerals, amino acids, and feed additives. So you can see the difference between the current diets and how less diverse we have become. And this is the root of the problem, what we have faced today. If you go back to 1940s, we are talking about at least 8 or 9 different ingredients, some of them in high amounts, most of them in small inclusion levels. And this is how the future should be. Major ingredients corn soybean meal plus a number of small ingredients to cover the formulation. So we have become less diverse, but we need to become more diverse. Just to show you what we did in 1940s, late 1940s, makes sense because the explanation is simple and straightforward. Because these are the broilers of that era. What you see here is the winner of broiler competition in 1952. You can just compare the size of the broiler to the current plant broiler carcass. So let us start with a simple definition of alternative ingredients. You could say these are ingredients not normally used in a country or a region. There are two types of alternative ingredients. One is what we call non-traditional. These are locally available, and we have known this for a long time. We have looked at it as potential alternatives from time to time, and obviously they have potential values. Then, of course, there are new and what you call novel ingredients which are coming into the market, which are previously unknown. We didn't even think about this, and these are emerging alternative ingredients. But what is important is that this definition is not fixed. It is flexible. And as I'll give a couple of examples, the definitions related to the location and the time we are talking about. Because an alternate ingredient in one region can be a common one elsewhere in the world. Also, alternate ingredients at a given time point can become a normal ingredient into the future, sometime later. A classic example is wheat. So you can see this is a very old paper, 1920s, and you can see two birds which are fed on maize and wheat. And the figure 2 is, you can see, and the conclusion of this particular study was wheat ration will terminate chicken life in 3 months. So it led to poor growth, and eventually the birds died. And it was attributed to a toxic factor in wheat, which we did not know what it was, which was not identified until the 1960s, when we realized with the advances in analytical systems, it was non-starch polysaccharide, the NSP, is the one which is causing. And then in the 1970s and 80s, we also had the NSP enzymes. And as a result, today, wheat is a common ingredient in many parts of the world. So the definition of alternate ingredients is time related as well as location limited. And essentially, the what is called as ordinary ingredient with advances in technology and understanding, we can actually make it a normal ingredient in the location we are living. And anyway, the constraints of ordinary ingredients have been discussed in forums over the past several decades. Some are socio-economic. We are going to talk about those. Some are technical, which are relevant, and most are nutritional. And of course, the major deterrent to the use of or inclusion of the ordinary ingredients are the availability, the supply, which is this, and the cost. If the availability and cost is occur, right, then there will not be ordinary ingredients. They will become slowly with sufficient discussion on technologies, we can actually make them a normal ingredient. And talking about the nutritional constraints, we have known, like I said, we have known these constraints. These are well documented. So I'm not going to talk about supply and cost at this webinar, because we all know these are the two major deterrents why the ordinary ingredients are remaining non-traditional. But what I'm going to do is I want to look at the choice of ordinary ingredients in the context of quality. What is quality? How do you define quality? It's not easy to define quality, and the simplest definition is fit for purpose. How does the ingredient fit the purpose for which it is being used? Yeah, and some of the nutritional limitations which we can actually mitigate listed here. I'm not going to go through each of them. Essentially, palatability is an issue with most ordinary ingredients. Fiber, which we currently called as NSP, and the presence of various anti-nutritional in different feeds, and the additional costs in terms of supplementation or processing, variability, which is greater than variability is in all the ingredients, but it is much greater in the ordinary ingredients. And the other general feature is the AME and amino acid digestibility are lower compared to the traditional feeds. And the last one is also important because one of the major problems we have with alternate ingredients is we don't have reliable data which we can use in our feed formulation in relation to the AME and amino acid digestibility. So we'll start with corn. I'm not going into details, but I will, when you talk about the alternatives to corn, of course, the first thing which comes to our mind is wheat. Wheat is not used in many Asian countries. It is, but it is the major energy source in poultry diets in Europe, Canada, and not far away from Asia, Australia, and New Zealand. It is quite often the only energy source used in poultry diets. The potential of wheat is that it has higher protein than corn, and it's a good energy source, as you can see, but lower than the so around 30-50 kilocalories or 3100 kilocalories. That's a cutoff point, but it is lower than, as you can see, lower than the energy AME content of the corn. Uh, but the problem is it's a viscous, what you call the viscous grain. It has high levels of soluble uh, non-starch polysaccharides, specifically type of polysaccharide known as Arabidopsis islands, and which causes mainly that's a factor which causes extreme nutrient variance. So we have two problems. One is slightly lower energy content than corn, but the soluble NSP creates a number of problems when consumed by birds. What is seen in the slide is the reported variability in wheat. It's a highly variable grain. For example, if you look at the protein, we are talking about 8 to 20% protein. And look at the starch, it's 40 to 70% starch. And similarly, you can see a wide variation in about 7 to 15% NSP, total NSP, and 1 to 4% soluble. You might think 1 to 4% is nothing much, but it has big impact on a number of things in the bird. And the other point to note is not only the level of NSP, but also the structure of the NSP, which will be different in different wheats, will have a big impact. What you see in this slide is how variable the AME of wheat is. So it is a nightmare for the feed formulators or nutritionists to formulate diets when given the option of wheat, because as you can see, there's a concept called low AME wheat, which is not uncommon at all, where you can see the AME can vary from this is a standard NRC value, 2160 kilocalories, and anything less than 3000 kilocalories, we call it low AME, and anything more than this NRC value, we call it high AME wheat. And both type of wheats exist in the practical sense. You can see the variation is between 2200 and almost 4000 kilocalories. So you can imagine the situation we put the feed formulators in. And again, it's a variability you see everywhere throughout the globe. This is from different countries, Canada, Australia, UK, New Zealand. You can see anything from 2000 kilocalories to almost, you can see 3900 kilocalories in some cases. So the real problem is this: how can we minimize the variation in terms of AME? Because this is the most costliest and important component in the poultry diets, energy. How can we minimize the variation? Currently, there's no way we can separate the low AME wheats from normal AME. Even though we have been working on this for past 30 odd years, there's no way you can look at a wheat and say, oh, this is low AME or this is normal AME. So that is out. But we have been very fortunate with the advent of NSP degrading enzymes, especially the xylanases, and it plays a safety tool when you use wheat in your diets. And essentially what I'm talking about is by adding the NSP degrading enzymes, you can essentially overcome the variation which exists. You can see down here, it reduces the nutrient variability between batches of wheat. We are talking about it's a safety margin. The enzymes will not have an effect on the high AME or only limited effect on high AME wheats, but it has a very big effect on low AME wheats. So essentially, we reduce the variability between different batches of wheat. So we don't actually need a test to separate low AME or AME wheat. Just a matter of including the NSP degrading enzyme, the xylanase, will be sufficient, which will essentially make it overcome all the arabidopsis problems. The next one is the barley, and again another viscous grain. The major producers are European Union, Russia, Australia, and Canada, and Ukraine. And Ukraine is a major producer of barley as well as wheat. And so you can see where the current crisis is coming from. So when you talk about barley, of course, it's much inferior to corn. It is not well done. It's poorly palatable, and it has a lower energy content compared to corn and wheat. It has a high fiber content. That's the reason why we have a low energy content. But also it has a high soluble non-starch polysaccharides, beta glucan. And also what you see is, again, just like the wheat, variability is a big issue. But again, just like wheat, we can actually overcome these limitations by enzyme, adding a supplemental enzyme. In this case, it's beta glucanase, and by pelleting. And just to give you indication of what sort of variability we are talking about, it's mainly coming from different cultivars of barley. You may think barley is barley, but actually we are talking about there is what you call normal starch. It varies in starch content, normal starch. And so if you are going to use barley, you need to find out what exactly it means. Is it in terms of starch as well as the presence of hull? Hull barley could be expected. It will have higher fiber content and especially insoluble fiber content. And also you can see compared to wheat, it has the NSP contents higher and different bit among different barley cultures. Just want to show the variation we have, and also if you are going to use the barley, please make sure what sort of barley you are importing or using. So again, just want to highlight that the NSPs in barley and wheat are different. In barley, we have beta glucans, which actually seem to have a much higher adverse effect on the bird compared to the Arabinous islands in wheat. So the barley NSP is not equal to wheat NSP. Again, luckily for us, we have been very fortunate the presence of the advent of enzymes, NSP degrading enzymes. Here we are not talking about xylanase, but we are talking about two different types of beta glucanase. Both are very effective in overcoming the adverse effects of the barley in poultry diets. And here we can see they work on all different kinds of barley samples. I think there are about 8 different samples here, and with different viscosities. And you can see higher the viscosity, these two samples, B6 and B3, higher the viscosity, the improvements are much greater. For example, in this case, it is almost 400, 500 kilocalorie advantage when you put the enzyme. So there's a simple solution. Barley is inferior because of the presence of non-starch polysaccharides, but it can be resolved. So wheat, we can completely replace corn with the addition of enzymes, but not in the case of barley. And these are from massive studies where we have seen uh, possibly you can replace 25% of the corn or wheat in broiler diets, but of course the inclusion level can increase with age of the bird. What are the other options? I'm going to go a bit faster. It's sorghum is an important grain. The major exporters are US, Argentina, and Australia, but the major consumers in broiler diets is Australia and Mexico. The advantage of sorghum, as we all know, this drought-tolerant crop and can be produced very economically in hot and dry climates. But it is not a non-viscous grain. It's a non-viscous grain, as you can see from the graph here. So it's more or less similar to corn, but of course much different from wheat and barley. So, but nevertheless, sorghum-based diets, if it's not well balanced, can be associated with poor broiler performance. The reasons are these. One is the starch is not well digested because of the presence of these three factors. Phenols, it's a type of tannins, and phytate, and also a protein known as caffeine. Most of this work has been done in University of Sydney by Peter Selle and Sonia Liu, and they call this a sorghum Bermuda Triangle. These three factors, the phenols, caffeine, and phytate, create this problem with starch digestibility as well as amino acid digestibility. The caffeine is not well digested, and also it creates a poor protein quality issue. Next slide, please. So, yeah, there's always confusion over tannins and polyphenols. So these are two different polyphenol. Tannin is a polyphenolic compound, but it's totally different from polyphenol. And sorghum may contain up to 10% polyphenol and 2% tannins. And typically the tannins are much lower in light colored sorghum cultivars, the white sorghum cultivar. And currently, if you are importing from US or Australian sorghum, Australia, the sorghums are tannin free. This has been a successful elimination of tannins through breeding of sorghum varieties. In fact, it has happened in many other plants also. And just want to point out the amino acid digestibility in these four grains: corn, sorghum, and wheat and barley. Wheat and barley are much lower compared to corn. And this is for the amino acid digestibility. But if you convert this into amino acid content, that is digestible amino acid content, you can see sorghum and wheat comes on top. And corn, because of the low protein content, contains much lower digestible amino acids compared to sorghum and wheat or even barley. So how about the enzymes? There have been some studies which shows that carbohydrates actually has some effect. If there's an effect, then it is not due to viscosity reduction like we see in wheat and barley. Some other mechanism is involved. There's also reports from University of Sydney. Specific proteases have the capacity to degrade the caffeine, which is the problem protein in sorghum. And this enhances protein digestibility, starch digestibility, and AME. Next one, please. The next one is cassava. I'm not going to talk much about it. Um, and the potential is it's low fiber, highly digestible starch, and the pellets. So there are different types of products. I'm mainly going to talk about cassava pellets. Different types of commercial pellets are available. The AME of which can vary from 3,200 to 3,800 kilocalories. And the major producers are these are the major producers, but only in two countries. The supply of cassava is more than the consumption, Thailand and Vietnam. So these are two countries where cassava can play an important role. But the limitations, of course, is it has a low crude protein, only 2 to 3% crude protein. It is dusty in nature. On its own, it's poorly palatable. Typically, you see its contaminants sand and hydrocyanic acid could be an issue if not processed well. But it could be used in poultry diets, not as a complete feed. In poultry diet, up to about 30%. Rice bran. Again, Asia is a major producer of rice, India, China, and Japan. And the major exporters of rice are Thailand, India. And so what it means, during the milling process of rice, there is also a byproduct, a very important byproduct, which comes out and potentially useful in a good quality rice bran, depending on the mill type. If it's a good commercial mill, there are different types of qualities, and the good quality rice bran, we call it rice polishing, is referred to as 13, 13, 13. That it means 13% protein, 13% lipids, and 13% fiber. So it has some beneficial effects. It's highly palatable at the same time. But the limitations are it's bulky. Because of the fat, it can become very rancid quickly. And also it contains trypsin inhibitor, which needs to be deactivated. The other problem is it is probably one of the ingredients which has the highest phytate content, so which in itself creates other problems. So there's a need for processing and antioxidants, so which adds cost. And inclusion level, depending on the broiler performance, we are talking about 5 to 20% in broiler diets. Anyway, it's a highly variable product, and the composition and the quality is influenced by the type of milk. And in some countries, of course, it's defatted because oil is so valuable, and in which case there are a number of things happen, especially the metabolized energy and amino acid digestibility will drop. So to give a summary of alternatives to corn, with enzymes, wheat can completely replace corn, and barley can partially replace corn. Again, sorghum can partially or completely replace corn. The past problems with corn has been due to the high tannins, but the current cultivars are low in tannins. So what are the alternatives? Soybean meal, a list of things which are given here. You can have a look. I don't want to go through each of them and talk about the potential. Canola meal, of course, stands from Novus number one. Then you have the corn DDGs, grain legumes. Because we are in Asia, I have also included palm kernel meal, and there are a number of other options which are available. The grain legumes, here we are talking mainly about the peas, field peas, faba beans, and lupins. They are moderate to good source of crude protein as well as amino acid digestibility and energy. But of course, most of these have some sort of anti-nutritional factors, many of which have been eliminated by plant breeding. But of course, we also have the option of extrusion, removing the hull, and like I said, the low tannin cultivars are also enzyme. So they could be included. It's very common to have grain legumes in European diets or Canadian diets. It's You can use up to about 20 to 30% if properly processed. Palm kernel meal, the major producers of common kernel meal in Asia, Indonesia, Malaysia, and Thailand. So we have a lot of palm kernel meal available as a byproduct of extraction of palm kernel oil or palm oil. And so it has some potential in terms of availability, but you can see the protein content is very low. In the case of solvent extraction, it could be even only 80%. So the problem is low protein and the texture, which is gritty and poorly digestible and can damage food processing equipment, and also can be a problem when you feed it, if you feed higher levels to poultry. And the problem is the low amino acid digestibility. We are talking about 50 to 55% digestibility. Just want to point out, you have heard and read a lot about insect meals in recent time. The production of which seem to be increasing commercially, and interestingly, 7 European countries have approved use of insects as a human food, but currently it is mainly for pet food and aqua feed, and that is limited to these 7 ingredients, and still it is not allowed on poultry and pig feeds, and the approval by the society to feed poultry or pigs with insects seems to be increasing. So the global production in 2018 was of black soldier fly is 6,000 tons. By 2030, it is supposed to be increased by more than 10 times. As you know, in the future, sustainability is going to become very, very important. And in this context, the insect meals will become more important. Here we are talking mainly about the black soldier fly larvae meal, which seems to be the top priority or top interest. And you can see the advantages. And it has high protein, up to about 55-60% protein, higher fat content, and higher amino acid digestibility is similar to soybean meal, and also the AME content, depending on fat content, could be as high as 4,500 kilocalories. But the main problem we have with many of these insect meals, despite the fact the production is increasing, the companies are investing on production of insects. There is still, we have not seen much data on the AME or amino acid digestibility. In the case of AME, I have seen only two published data. In the case of amino acid digestibility, again, the same thing. We have seen only two amino acid digestibility. So these companies essentially need to invest more on proper feed evaluation, and the inclusion level at this time is open for discussion. The next one is the green meals. Again, we have a similar problem. The problem in green meals, some of the data here, and so we can actually grow this without any need for land, very high yields, high protein when dried, but the drying cost is very high. So the alternative summary is alternative source to protein nutrition is soybean meal cannot be completely replaced. You can take off part of the soybean meal by addressing few things like maybe you can use reduced protein diets, which will reduce with the addition of synthetic amino acid, which will take off some of the soybean pressure on soybean meal, and use of enzymes with not only soybean meal but also with the alternative proteins, and the inclusion of the alternate protein meals, and canola meal and DDGS, etc. So one of the things which is, I'm sorry I'm taking a bit longer, but I'll try to finish it as soon as possible. Anyways, there are risks. In addition to the nutritional risk, there are a number of other issues which are very present when you use the main two ways by which you can mitigate these risks is one by feed evaluation, which is energy, and we are specifically focusing on energy and amino acids, and then feed additives. The evaluation of available energy in alternate ingredients is very critical because of the fact that energy is a costliest item in poultry diets. And the AME is a system which was introduced about 60, 70 years back, and we are not changing. Still, we are using this system. And where do you get these values? From tables and books. As a feed formulator, where do you get these values? Some of you may, depending on the size of the company, you may be getting the value from tables and books. And many of you also use a combination of prediction equations, so which is available for the common ingredient. But of course, the best test will be animal trials, the bird trials. But these are going to be main constraints with alternate ingredients because these options are not available for alternate ingredients. Whereas the AME has stood still, we are still using the protein evaluation has moved from in the 1950s. Our diet, I don't know whether many of you know that, our diets are formulated based on calorie protein ratio, just protein. And today, we formulate diets, most of us at least formulate diets on the basis of amino acid, elite amino acid digestibility, and what the term SID has become become a norm. But the issue is the amino acid digestibility differs among ingredients, and it gives the opportunity to improve the diet formulation in containing alternate ingredients while maintaining performance. Next one, please. Anyway, this again, I'm not going to go into details. So these are some things you all know. And the lysine digestibility can vary in feed ingredients, can vary anything between 55% for cottonseed meal and feather meal to over 85% in the case of soybean meal. So when using poorly digested alternate ingredients, feed formulation on the basis of digestible amino acid, it's mandatory. Moving to feed additives, there are hundreds of different feed additives which are available as well as used in diet formulation. But the additives of interest in relation to alternate ingredients will be feed-grade amino acids, feed enzyme, antibiotic replacers, which I'm not going to discuss today. Next one, please. Feed enzymes. Next one, please. The important point about feed enzymes is each enzyme has a specific substrate. These are the major feed enzyme groups. So microbial phytases, and in the NSP enzymes, amylases, proteases, and carbohydrates and lipases, all these different things. The point is, if you look at phytase will not act on carbohydrate. It has a specific substrate, which is phytate. But the substrate does not exist on its own. So when you feed ingredients, what you see is substrate in complex matrices. The important take-home message is that the potential value of ingredients are not realized at the animal level. No ingredient is 100% digestible. There's always, even for enzyme, substrate for which digestive enzymes are produced, still there is 10 to 15% of protein, starch, and lipids are typically undigested. So there is undigested material remaining following the normal digestion within the bird, and this is the rationale behind the use of exogenous enzymes. It's the reason why we put the exogenous enzyme, because no nutrient or no ingredient is totally, completely digested. So the next option is the feed grade antibiotics. So we are talking about methionine, lysine, threonine, tryptophan. These are common amino acids, and of course there are other ones which are emerging or becoming more valuable. And these can play a very important role in formulating diets or for overcoming the nutritional limitations of alternative feed ingredients. The focus, I just made a point about threonine. When you feed alternate ingredients, there is a lot of mucus secretion, and the major component of which is threonine. So what it means is when you are increasing the levels of alternate ingredients, it's important that you focus some attention on threonine. When you're using alternate ingredients, very important you target the inclusion level. It's not just a matter of putting the alternative materials. We need to know what inclusion level should give you the best results. But of course, the inclusion levels can change depending on the age of the bird, the genetics of the bird, and also the fact which should be remembered is one of the reasons why we did not use alternate ingredients in the past is because of the fiber content. But today, fiber has become an essential component. In other words, actually, alternate ingredients can be beneficial. So how do you do this? If you have an alternative material in your hand, or available in your location, or available to your feed mill, how do you start? The first step is available literature, review of available literature, which, as mentioned earlier, an alternate ingredient in one region may be a normal ingredient in some other region. And so there is typically, we find quite a bit of published data. And once you have that, you can actually pinpoint a certain level of inclusion level under your conditions. And then you can plan experiments and pilot experiments at first. And so many of your companies will not have any research facilities to do these trials, but I am sure in all the countries, there are universities which can do these trials and which you can use and which can help you to fix this inclusion level. This is something I'm not going to talk much about it. And one of the problems we have with alternate ingredients, because of the fact they are not well digested, that is one part of the story. Other part of the story, they also have components which trigger a mucosal inflammation, and which is a health condition which lowers productivity even without you realizing it. And for example, gut integrity, leaky gut, and dysbiosis all these part of the symptoms of. But currently, there's a lot of research, and we know what is causing this and how it can be mitigated. The variability is an issue in all the ingredients, and this is going to be a major issue with alternate ingredients. End thought of my presentation is this: we are in the middle of the perfect storm, and this will continue at least in the short term future. And if certainly the industry has to start planning to make the diet formulation more diverse from corn and soybean meal. And some of the opportunities are listed here: data feed evaluation, need for quality control, inclusion levels, digestible amino acids, enzymes, and use of feed grade amino acid. Thank you very much, and I'm truly sorry for taking a bit longer time, and hope you enjoyed the talk. Thank you.
Thank you. Thank you very much, Professor Ravi.